It says individual or group. Do you like how Mr. Smith and I have saved our hide either way? Some years we do it individually. Some years we do it as a group. But you should be able to graph this. Guys, first of all, should I graph it when it's just like this right now? No, because is it in standard form? No. So the first thing you need to do is change it to standard form, which is A times the cosine of B times quantity X plus or minus C plus or minus D. So I need to get it in that format. And the one that's all messed up is B. So when you're looking at it, you rewrite it, you go negative cosine, and what do I factor out of that quantity? 2x plus 5. A 2, which leaves what, my friends?
X plus pi over 2.
All right, plus 1. Now, shouldn't we be able to pull out all of our information and give a good verbal description for it?
Yeah.
So remember, this is how I literally graded you on your quiz. So for A, it's a -1. What does that tell me verbally? Yep, perfect. So flip over x-axis. All right, what's B? 2. But what are we looking for? What's the verbal for this one? Yeah, 2 pi over 2, which gives us our period length of pi units. All right, guys, what's C? Yep, a positive pi over 2. Now, this would be perfection if you guys would have done this. Most people did a pretty good job, but some people just left the word shift out, and I'm like, not going in there with you. You have to give me at least a little bit more than that. What type of shift is this? A horizontal one or a vertical one? Horizontal. So this would be absolute perfection if you said that. So horizontal shift, which way? Yep, so we're going left, pi over 2. What I needed to see was at least shift left pi over 2, right? When you're doing that. All right, what's D? Yeah, so it's a +1. So again, ideally you'd say what? Vertical, and then you'd say you'd shift up 1. All right, now when we're graphing this, my friends, we do the first two together. So we go ahead and we mark our period here. And again, if this was what was on like a test and you didn't like the scale, could you change the scale? I'm fine with that, as long as you mark it clear, just so you know. So then with this, it says you have to flip over a -1. So also make sure that you remember it's cosine curve. So instead of being at the ends at 1, you're at the ends at what value? Yeah, -1. So we're here at -1, and -1, and then you go halfway. We go up to +1, and then half of the halves are your zeros. Exactly. And guys, making sure we have a nice curve with that. Pretty good. Now, we have to do our last part here. Let's go in blue. This will be our final graph. You have to do the horizontal shift and the vertical shift, and you need to do it for all 5 points. I had a few people, I don't think it was in this room, but I had a few people only give me 3 points. And what was the very first thing I taught you about sine and cosine graphs? I have to see how many points. 5. So the rules don't change. So with that, we go left pi, which is 1 space, and then we go up 1. Left pi up 1, left up 1, left 1 over pi over 2, 1. And you should have had a graph that looks something like that. As good as I'm going to get today. Now, does the graph truly stop right there? No. Now, you don't do more than this. Just watch what I'm doing here. Doesn't the graph just literally keep going like this over and over? Would you guys agree? Except for unless you know you're the teacher who keeps using her finger on her select key. Okay. I know I'm not doing that. I'm holding it differently. Is it going to stop, do you think? All right, eventually it did. Okay, good. But I had a horrible graph at that point. But I'm moving on. Now, doesn't the graph truly go on forever like this? Now I'm going to ask you the questions that we were talking about with functions. What is the domain for this function? What's your domain? Everyone go ahead and write this down. What's your domain? Where does domain come from? The x. So it's my input, right? So what's my x values for this? If it goes on periodically, which means forever, horizontally, it's what? Negative infinity to infinity. Right on. You guys remembered. Great job. Negative infinity to infinity. Now, range. What do we get there? Yeah, our lowest value we get is 0. Do we actually include it? Yeah, it's supposed to be touching it right there, correct? On all of these. So I can include the 0. How high do I go with this one? You only go as far as your outputs go. Once my outputs go to what value? 2. Our range goes from here to where? There. It's from your minimum value to your what? Maximum value. So remember some other terminology that you're going to see on here. Like this is a maximum. Now, it's called relative maximum because we have lots of them. But what is your maximum output? 2. Are you seeing where your max value comes from? It's the top of your range. What do we call the values down low? Minimum, right? And since we have more than one, you have the relative minimum. But what is our minimum for that graph? 0. So understand the range also gives you your max and your what? Min. Your range also can tell you your amplitude. Ignore the fact you know your amplitude's a -1. The negative just means you flipped, correct? But the 1 tells you go how high? 1, and you go how far down? 1. Okay, now I want you to think like this. How far apart is your max and your min? I'm up here at 2 and I'm down here at 0. How far apart are those? A distance of 2. What's the amplitude? Careful. What's your amplitude? It's still 1, right? Yeah. You go up 1 and you do what? Down 1. So if you're looking for amplitude and you know the range or the max and min, it's just half of it. Does that make sense? Notice I said the distance between, right? The max and the min. Your amplitude, that's the number you go up and you go down. So if you're talking about range, that includes both of them. Does that make sense? Does it kind of make sense? You guys with me so far? Should we try a problem together so let's see if it really makes sense? Okay. I'm not going to worry about this. I think you guys can figure out domain and range on number 2 on your own. This, I want everyone to look at me, is going to be on your test. Is that blunt enough? This critical thinking worksheet is brilliant. It really makes sure you understand graphs and you understand how the functions are being described. I want the equation of the graph below. Note, it says there's more than one correct answer. Because guess what? There is. It matters on what you physically see. Now, do you guys agree with me this is a periodic? We know it has to be sine or cosine because there's arrows saying it's doing what? Going forever. Now, I'm going to ask you a question. I just want your first instinct on it. I want you to look at it right now and tell me, do you see a sine curve or do you see a cosine curve? Cosine. Okay. A whole bunch of you said cosine. Did anyone see sine? So this class is more cosine than sine? Okay. Where did you see the cosine curve at?
Oh, I see the sine curve.
You see it as the middle, so you see it right here. Is that where you see it?
I see it from the
Or
top.
did you guys see it this? Some of you probably saw it this way.
That's where I saw it.
You see where you see it makes a difference. Like if I saw it like this, would you guys agree with me? All of a sudden I saw a reflection, right? But if you see it over cosine going from here to here, would I have a reflection? No, right? Would you guys agree with me how you could see this differently? Okay, anyone see the sine? Seriously, I only heard the cosine people. Did anyone see a sine curve? Does anyone see it from here to here? Here's the cool part. You're right if you saw it either way. Because here's the thing you need to know about sine and cosine curves. The cosines, one's just shifted to the left, pi over 2. Right? Remember when we put the sine and cosine curves on the same calculator? One's just a horizontal shift of the other, however way you want to describe it. You can do this. So, Do you guys want to do cosine since that's what majority of you saw? All right, so let's do cosine. I'm going to go with this one from here to here just because I don't want to have to deal with negative values right now. Now, when we don't give you a scale, which is not fair, I absolutely agree, you may go ahead and assume it's the normal pi over 2 for our horizontal scale, and you may go ahead and assume that our vertical scale is the normal one. So you may make that assumption if we don't give you a scale. Now, looking at this, we're going to use the idea of a cosine curve. So we're going to write it in standard form. But the key thing is we have to pull out A, B, C, and D. The first two should be the ones that you graph first too. Find A and B first. Now, how can I go about solving for A in this one? Yeah, you should be able to look at the graph. Would you agree with me? This is over here at like a positive 3. Where's my minimum at, guys? At negative 1. How far apart are these two? Well, how far apart though? 4, which means my amplitude must be what? Positive. We're going the positive on this one, right? Because the distance between my maximum and my minimum, or aka my range, is a distance of 4, but my amplitude is going to be what? Half of that, because you go up half and you go down half, right? When you're doing it. So you just told me A is 2. Guess what? It was going to be 2 if you did sine or cosine. Okay. Now, what's B going to be? Now someone goes like, well, how do we figure out B? It only goes to pi? Doesn't it go more than pi? Isn't the distance from a start to an end a distance of 4 pi? Would you guys agree? Because what do we have? This is all going up pi over 2. So this would be pi, 2 pi, 3 pi, what? 4 pi. So remember, the period is the length for one full going through the curve, one full cycle of this. So we know the period is 4 pi. So what's going to be B? No, what's the question? Yep.
I have pi over 2 as
Every block, right.
so
So pi over 2, pi, 3 pi over 2, 2 pi. How did you get that? Because it's 1/2.
I just did it.
Okay, which, hopefully because we've done a lot of this, but here's the easy math for it. Are you guys ready? So you can just have the math so you don't have to guess. How do we find the period? That's 2 pi over what? Over B. So we know that equals 4 pi. Guys, if in doubt, cross multiply. You know I love cross multiplication. We should know this at this point in this class. Look what happens. We got 4 pi times B. This is 2 pi. Look what Mitch got. Mitch, should we just kind of know from the trends that we had before, shouldn't that be 1/2? So B is 1/2. Guys, are we in a pretty good place right now? So think about this for a moment. If I was graphing this, my original amplitude is 2, my B is 1, so the period's 4 pi. If I was really graphing this originally, here's pi, 2 pi, 3 pi, 4 pi. We'd be up here at 2, 2, halfway. I make sure I go halfway, down to. This would be like our original graph. But I need to get to where the yellow one is. What's my horizontal and vertical shift? Up 1. So D is going to be +1, right? What's going to be C? Right or left? We're going, not -1, negative what?
Oh, negative.
I'm going to the right, so negative pi over what? Because one box is a distance of. So you're are we kind of working backwards is what we're doing? Yeah, so what's going to be our equation for this graph? We're going to go y equals, what's A? 2 cosine of 1/2. And then what do we have?
X minus pi over 2 plus 1.
Do you realize how good at graphing you are if you can pull that off? That's why we want you to be that good with it. So, what are you guys going to do the rest of this time? You are going to go through these, and you are going to be able to find domain and range. You're going to do true, false. This is all the stuff about the stuff you took your notes on. I'm going to go through and look at your notes while you're doing this with your partner. If you don't finish, it turns into homework. If you're finished, oh darn, you have a nice free weekend. I'm sorry that happens to you. But use the time wisely. Make sense?